Barcelona Supercomputing Center is the Spanish national supercomputing laboratory and one of the largest high-performance computing research centers in the world.
Our mission is twofold: to generate knowledge and technology, and to provide infrastructure and supercomputing services to Spanish and European scientists.
Supercomputers are wonderful machines that allow scientists and engineers to perform simulation and data analysis that require large amounts of data. They are used in a wide range of disciplines from biology to astronomy, engineering, and physics. Today, supercomputing is considered the third pillar of science, the other pillars being theory and experimental laboratories. It is an essential tool for accelerating scientific development.
At Barcelona Supercomputing Center, we strongly believe that the knowledge and technology that we generate must benefit society, both in terms of quality of life and competitiveness. That's why, as well as collaborating with the public sector, we are fully focused on undertaking joint projects with the private sector, such as promoting the creation of new businesses.
In the Computer Applications in Science and Engineering department, we develop parallel software to simulate complex physical phenomena. Our software, ALIA, is designed to fully exploit the capacity of a supercomputer and has broken records, running on hundreds of thousands of processors efficiently. ALIA is able to perform coupled multiphysics simulations. This allows us to simulate very complex industrial processes like interaction between ocean waves and a wind turbine tower, or biomechanical occurrences such as transportation of particles in the human respiratory system or the workings of the human heart. Because energy is essential for industrial development and overall quality of life, the energy industry is one of our main focuses. We have long-term agreements with companies such as Repsol and Iberdrola, under which they can take advantage of our simulation software for their business activities. We undertake work in exploration geophysics, chemical reactors, batteries, and wind farm modeling. Another key activity is carrying out simulations to help design better combustion devices and fuels. With energy for the future in mind, we have also begun work on modeling fusion reactors. In addition, we work on ways to improve how we manage our communities. For example, in our smart city projects, we develop software to analyze pollution and mobility patterns or to improve urban design.
In the Life Science Department at the Barcelona Supercomputing Center, we aim to understand how living organisms are, so how they work, how they perform. We want to somehow transform the bio problem into an engineering problem. We want to understand the rules, the equations that define lives, to use this equation to actually predict the behavior of living organisms. With this broad interest, we are working in two different areas. On one hand, we are working in trying to understand the mechanical behavior of biomarker molecules, proteins and nucleic acids, trying to understand them as machines, because in fact, they are biomachines. On the second area, on the second hand, we are working in trying to develop methods to take the most of information from genomic proteins. So we're trying to get use of this massive amount of information that comes from sequencing to understand the rules governing the behavior of human cells and to understand the origins of pathologies and eventually how we can treat these pathologies.
In the Earth Sciences Department, we carry out research in Earth system modeling, which aims at better understanding the ocean, atmosphere, cryosphere and land surface. We conduct research on emissions, air quality, mineral dust transport, and global and regional climate modeling and prediction. And with the aim of sharing the results with other sectors, we develop services to facilitate their take-up by industry and society in general. For instance, we provide high-resolution operational air quality forecasts at the local and regional scales, information that is provided publicly using both web and mobile applications. This has resulted in BSC becoming the first regional center in the world designated by the World Meteorological Organization to publish atmospheric sand and dust forecasts. We are one of the few institutions in Europe able to formulate global climate predictions. We use the climate information obtained in these predictions in renewable energy models that optimize energy production. Finally, we share our supercomputing expertise by helping other scientists to improve the efficiency of their Earth system models and to address big data problems.
Executing such complex applications and simulations would not be possible without supercomputers. Thousands or even millions of processors working in parallel to execute a single program and delivering processing power up to millions of times higher than that of personal computers.
Since the 70s, the performance rate of supercomputers has been multiplied by 1,000 every decade. At the same time, their components have become increasingly small, in some cases the size of just a few atoms. This evolution provides growing opportunities to science, but also causes problems of variability, scale, and energy consumption, as well as making developers' work more complex.
In the computer science department, the biggest department at BSC, we work on developing increasingly powerful architectures and on providing a productive environment for application developers. We develop tools that allow us to obtain a precise insight into the actual behavior of systems, so we can provide guidelines on how to improve their efficiency.
We also aim to keep the computer's complexity hidden from scientists and programmers, letting them focus on scientific problems. Our programming models and environments dynamically distribute computational tasks among different processors, optimizing performance and minimizing data movements. These models and environments work on both compute-intensive and big data programs. They are in continuous development and are increasingly used by the international computing community.
Finally, we work on new computer architectures where hardware is optimized to better support the program environment. And we undertake research on architectures based on low power and low cost components to make future supercomputers cheaper and more energy efficient.
In the operations department, we take care of Mare Nostrum, the biggest supercomputer at BSC, as well as the other BSC high-performance computing and data management facilities. With these facilities, we provide services to the scientific and engineering community in Europe, Spain, and BSC. Scientists from across the world who need to run large-scale applications at the highest performance level can access these facilities by applying to the Spanish Supercomputing Network, coordinated by BSC, or PROACE, the Partnership for Advanced Computing in Europe. Access is free for offering research and development and is always subject to a peer review process, which includes an evaluation undertaken by technical experts and leading scientists. We provide training and support services for users to help them adapt their applications to supercomputer architecture and to make the applications run efficiently. During its first decade, BSC has provided services to more than 3,000 projects from disciplines as diverse as biology, physics, astronomy, and engineering.
Without supercomputing, the scientific breakthroughs of the 21st century will not be possible. At BSC, our goal is to continue making those dreams a reality.
We work to drive scientific, economic, and social progress forward, and to consolidate Barcelona's position as a globally recognized innovation and technology hub.